Hi, it's Jan Beta, and today I'm going to try to repair this Commodore 64 shortboard that I found on my pile of things that have to be repaired. So this is a Revision A 250469 Commodore 64. Seems it's from late 88. Most of the chips that were soldered on the board here have a date code that is somewhere around the 40th to 45th week of 1988. The VIC-2 chip is from the 3rd week of 89, according to the date code. This was replaced. And other than the SID chip missing, and I think the VIC-2 was probably missing when I got it, this had a missing fuse when I got it. I already replaced that. Other than that, this board seems to be in relatively nice condition from the initial visual checks. It's always a good idea to see whether there are components missing or maybe something looks burnt or cut traces or things like that. I couldn't see anything, but I didn't really look at this in much detail yet. I wrote on here RAM ? So maybe this has a RAM fault. We're going to find out using all my tools in the arsenal. Unfortunately, I can't really remember who sent this to me. This was definitely sent to me by a viewer of this channel, but I don't remember who it was. I didn't note that down. I'm sorry. If you sent this, please let me know in the comments, and I'm going to thank you in the reply. Thank you, whoever you are, for sending me this. I apologize for not being as organized as I wish. There's a bit of solder residue on the backside here, particularly around the crystal here, but these might all be components that were hand soldered at the factory and they just didn't bother with removing the flux. Many C64 boards look like this. So I already powered this on briefly. And all it displays is a black screen, which is the most common fault in Commodore 64s, and it can be caused by almost every single component on this board failing. So we're going to go through this step by step and try to figure out what's at fault with this one. Just powering this on briefly so you can see that it is a blank screen. The VIC-2 is good. I tested that in another machine. That's why I already wrote OK on that chip. And it's also not the one that was on here. It didn't come with a VIC-2 as far as I can remember. This is a classic blank screen or black screen. It displays a PAL signal, outputs a PAL signal, so that hints to the timings of the video to be correct. So I guess the timings in this are working, at least the ones related to the video circuitry. I'm going to check the voltages on the board, which is always something you should do. There's no SID chip on this board, but that doesn't prevent a Commodore 64 from at least displaying the startup screen. You won't have any sound without a sound chip, of course, but other than that, the machine should pretty much work as expected. And it's always a good idea to remove the chip in case something's wrong with the voltage rails, just to prevent damage to the chip. And the SID is socketed on most Commodore 64 boards I've seen so far. The VIC-2, unfortunately, we can't really remove that because it also generates the clocks, the system clocks and things like that. So that is a vital chip to at least halfway function for the system to work at all. And to be able to troubleshoot this, we also need the VIC-2. Yeah, let's check some voltages first. So the Commodore 64 voltages for these short boards, the voltage supply is the same. So the voltages going in are the same as for the Commodore 64 long boards, but the voltages used on the board are slightly different. We have 9 volts AC and 5 volts DC coming in from the power supply, and then there's a secondary rail for 5 volts that provides the VIC-2 and the SID chip with voltage that is generated through a linear regulator on the older boards, the long boards, which are slightly wider, and there is a 9-volt rail that is generated on board, 9 volts DC for these smaller boards, the short boards, that provides the SID chip, and that is done just to provide cleaner voltages to those chips. The other stuff is powered directly from the 5-volt rail from the power supply. That's why failing power supplies are such a big issue with Commodore 64s. And in fact, the power supply that these shipped with originally are not really well designed, and that's why the power supplies fail so frequently. And in case the power supplies fail, pretty much all the chips on C64s can be damaged. So long story short, I would always recommend to use an aftermarket power supply. There's several options these days that you can choose from, and they are all more reliable than the original power supplies. I'm using a self-made power supply here. That is a modern power supply and a transformer in one nice housing, so the power supply is not going to be an issue. So what I usually do is to set this up to volts DC, and I measure on the user port here. That's where the voltages from the power supply go through. And we have, for the 5-volt rail, 4.98 volts. That's close enough to 5 volts. Then I set this up to volts AC, and that should be here. And that should be close to 9 volts. And we have 10.4, so that's pretty close. And we have some other voltages that are generated on the board. So we can measure the voltages that the chips get. We are going to have to measure 9 volts on the SID socket here, I suppose. Yeah, that's 9.4. And we should have 5 volts on most of the chips. The top right pin is the 5 volts supply. That's 5 volts. That's 5 volts. That's 5 volts. 4.99 on the processor. That's our ROMs here. 5 volts. 5 volts. Secondary CIA chip. 4.99. Should all be good. And the RAM has the voltage on the lower left pin. We have 5 volts going through all the chips. That should be enough to power the system. And we have 9 volts on the SID, which is the secondary voltage for the SID in the shortboard revisions. The older revisions had 12 volts there. So our voltages look good all across the board. Actually, all the chips get at least the 5 volt supply that they need to run at all, but we still get a black screen. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do CNC machining, 3D printing, sheet metal fabrication, injection molding. Pricing is super reasonable. They are friendly people to work with, and their service is excellent. So I highly recommend checking out the link in the video description. Back to our Commodore 64. So this should be safe to run for longer periods of time. The voltages on the board are correct, and we are not going to damage any chips through overvoltage or anything like that. So this still displays a black screen. It locks on the 50 Hz PAL signal, but we don't get any output there. So something is not starting up correctly. And as I said, can be a lot of things. Basically all of the logic, the RAM, the processor, the CIAs, everything needs to be working for a C64 to start up. So a black screen is not a good indication of what's faulty, really. So we could use an oscilloscope and trace the signals, and maybe we have to resort to that later. But the first step I usually take is to go to the diagnostic cartridges, which I have here. This is my little arsenal. This is a DAT test and a diagnostic cartridge. These were originally issued by Commodore. I made one myself, and the DAT test is a really good initial test for blank screen or black screen C64s, because that doesn't require most of the chips to work. Just needs a processor, some portion of RAM, VIC2, and the PLA to work. That is always a very good first test. And recently I made a video about the DesTestMAX, which is also running on the same cartridge mode that the DAT test runs, the Ultimax mode, and that also requires not much of the system to work to run the diagnostics. So I'm going to go with those first. I'm going to go with the DAT test as my very first step. As I said, this was originally issued by Commodore for their service technicians, and it indicates faults pretty quickly. It has an initial startup test where it actually flashes the screen if it encounters a RAM fault. So let's see. Yeah, that's 8 flashes on the screen. That indicates a fault with the RAM on the initial tests. So I'm using the DES test now, which basically does a better RAM test than the DAT test. Yeah, and there we go. It also shows me bit 0. These are the data lines on the RAM. And most of the bits are green, and bit 0 is red. And it also failed while testing the 0 page, which is the first section of RAM, basically, that the processor directly communicates to. So I would guess something is wrong with the RAM or with the communication to the RAM. And the fact that we get a picture output from the DesTestMAX tells me that probably our processor is working correctly, probably our PLA is working correctly, probably our VIC2 is working correctly, at least somewhat. It outputs a picture, which is also the same for the DAT test. If that screen flashing works, basically the processor works, the PLA works most of the time. It might indicate a RAM fault or a fault with the supporting logic to the RAM. The fact that only bit 0 is shown as bad points to one of the RAM chips. Maybe it's as easy as that. Maybe it's just a bad RAM chip. So what I'm going to do is to look up which RAM chip is indicated by the 8 flashes that we saw and the bit 0, which mean the same thing, hopefully. And then we're going to desolder that RAM chip and test it separately. This is the manual for the DAT test card. And 8 flashes indicate on a revision E C64, we have the U10 being faulty. Data bit 0, which is the same the DES test showed us. U10 is our RAM chip in question. And we have a very similar table in the DesTestMAX manual, and we have U10 for the 250469. The same chip indicated by the DAT test manual. So chances are that's our culprit. And that is U10, this chip here. I'm going to mark that. I think I want to desolder this and put a working RAM chip in a socket in there to see if that indeed is the fault. It might also be something with the traces that lead to this RAM chip. This is our RAM chip here. Traces look reasonably good as far as I can see. And the soldering also looks pretty good. There's one pin here, this one here, that doesn't seem to be soldered very nicely. There's no solder on this side of the board, but the back side, it is fully connected, it seems. So we should be good, really, and this potentially is just a bad RAM chip. And I'm going to pull it with my desoldering station. RAM faults are actually not that common on these newer boards because the RAM chips are far more reliable than the older, smaller RAM chips, and also there's less of them. So the probability of one of these failing is a bit lessened by the fact that there's only 2 RAM chips that together give me 64 kilobytes of RAM compared to the 8 RAM chips that the older boards have. But still, of course, they might fail. A couple of the ground pins didn't come out, but pretty much all of the other ones I managed to get. It's not quite as trivial to work on these newer boards compared to the older long boards C64s, because these are just way better boards and they're a bit thicker and the through-hole plating is a bit better, so the solder holds a lot better in these compared to the older ones. But not to worry, you just have to be more careful and take a bit more time. So what I like to do is to use some hot air to finish the job, basically. Usually I use the hot air from this side because the solder you can't suck out from the other side is mostly the solder on this side. I'm just going to use a chip puller and some hot air and try to slowly heat it up and wiggle it out. There we go. Of course, you want to be careful with the hot chip. Yeah, usually this kind of works in a non-destructive fashion, and I think I didn't lift any traces. We have to get some of the solder out still, so I'm using my regular soldering iron with some solder wick. I scraped a bit of the solder mask here, and one of the through holes here is still got some solder in it. and these two here. The ground plane connections, basically, these are the ones that are the worst to get out. But usually, with a bit of persuasion and a bit of solder wick, we are going to get there. Yep. It should be enough to fit a socket in there. I'm going to put a socket in no matter what, basically, at this point, because we need to put a RAM chip in there anyway, no matter if our RAM chip is the fault or not. And it's always good practice to put sockets in wherever you desolder a chip, just to make it easier to remove it in case it's still faulty or in case you want to test something or whatever else. I'm going to give this a better clean later. I think I could also replace the capacitors on the board while I'm here. But for now, I just want to see if we get this to work by replacing that RAM chip. Let's first see if our RAM chip is actually faulty or if it's something else. And for that, I suppose I could get out my Retro Chip Tester Pro. DRAMs, and this is a 41464, which I think is the same as a 4464. 4464 and 41464 are actually the same type of RAM, just different names from different manufacturers. So let's test this. So this might just be very broken. I think we found our culprit. Yeah, it doesn't even seem to recognize it. I'm going to have to look for a spare RAM chip. Not sure if I have these. So it turns out I have exactly 2 of those chips. 41464. I have a lot of 4164, which is the one for the older Bradpin C64s. But only 2 of these. But these rarely break. That is not a very common fault on the shortboard C64s. Could have tested this beforehand, I guess, while we have the retro chip tester out. Should have tested it, probably. Let's test it. It should be in there nicely. Let's try our tests again. Do we get the blue screen of life or do we have to do more troubleshooting? Blue screen of life! Hooray! Seems to be fixed. Yeah, so it was indeed what both of our test cartridges were pointing to. One with flashing the screen and the other one with a bit of a nicer on-screen display. Bit 0, U10, the RAM chip, was faulty. So chances are this is a fully working C64 again, but we're going to have to do some more testing before we can determine that. So I'm going to go through my test cartridges here. Let's do the DesTestMAX first, because I love this new cartridge and it's pretty new to me. And it does some more in-depth RAM testing, which, yeah, now it goes to the second screen and does some more testing of the RAM. And that should all be good now. I hope the other RAM chip probably is good if we get the blue screen of life from this C64, which we did. Nice. And then of course we need some SID replacement probably to have sound from this. Yeah, that passes all the tests. Just for giggles, let's try the DAT test again. This is the slightly updated version of the DAT test cartridge, the STID version, which I kind of like. Takes far longer to start up, but that's normal. A bit more in depth regarding everything other than RAM, basically. The RAM test in the DES test is way more in depth than what you get from this one. And we're going to do the full diagnostic test as well. I suppose. Yeah, and the sound test is not going to output anything because we don't have a SID chip in there. That's the main difference between the original DET test and this STID version. It does test the filters in the SID as well, which are a pretty common fault. Usually the filtering in the SID sounds weird at first if the chips gradually fail. So for some more in-depth testing of everything apart from the RAM, I now put an ARM SID in there, which is my favorite replacement SID chip. And I also connected the whole Diagnostics harness for the diagnostic cartridge and all the little connectors. So we're going to run the diagnostic cartridge and see if that throws us any errors. And this is a Commodore issued diagnostic cartridge from back in the day, basically in an upgraded version. And that tests the C64 a bit more in depth and tests the ports and things. Hence the harness that you need for this to pass all the tests. And this doesn't start up on a black screen C64 usually, because it uses the regular cartridge modes and just needs most of the system to work in order to run at all. So the DET test is a good initial test, or the DesTestMAX that we now have. And this is a test to see whether the rest of the system is working. And now we also get sound. Don't know if you can hear that very well, but I hear it. It seems to pass all the tests. That is promising. Another one fixed. I'm pretty certain at this point that this C64 fully works. I am going to play some games and things like that. Sometimes there are some slight issues with the VIC-2 graphics chip or some issues with the SID chip you don't catch with just using the diagnostic cartridges. But running some games that you know well usually rules out any extra faults. Sometimes with the VIC-2 chips, especially the older ones, you get some sprite flicker and things, and some colors that are not matching the original colors from the game, and some scrolling issues. Usually you can determine that pretty quickly with some games that you play. And I like playing games on the C64 anyway, so let's do that. This is Spaceman Splorf. Really nice little game. Kind of like a bit of Flappy Bird's take, or Flappy Bird, I don't remember. But a way nicer one. And as you can hear and see, our C64 indeed is fully functional. This gets tough really quickly in this game. Yeah, this C64 seems to work just fine again. It was just one broken RAM chip and we had to replace the SID with a replacement because I'm out of 8580 SID chips. Kind of an easy fix, but at least I've shown some of the steps I usually take repairing C64s, and maybe this helps you repairing your C64 in case it has a similar fault. I hope this was informative and maybe even a bit entertaining. Thank you so much for your subscriptions and your likes and your comments. And special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or through single donations, super thanks and things like that. You know who you are, and you're also in this list that is scrolling on screen now at this very moment. Thanks for watching. I'm Jan Beta. See you next time. Bye.